Welcome to our presentation on improving emotion annotation of music using citizen science. My name is Juan Sebastián Gómez, and I'm a PhD student under the supervision of Emilia Gómez at the Universitat Pompeu Fabra. Our work was carried out with the colleagues from the Music Technology Group and the Group on Interactive and Distributed Technologies for Education in the context of the Trompa project. Trompa is a European Union's Horizon 2020 project that stands for Towards Richer Online Music Public Domain Archives, and was presented in order to put a human-in-the-loop approach to enrich public domain music heritage. The idea is to exploit interest for public domain archives and have our pool of participants contribute to crowd annotation, while offering diverse applications developed for different use cases. In order to achieve this, we gathered several communities that go from musicology experts, music institutions, technological partners that develop applications, music users, and content owners. The idea of having a diverse community of actors is to enrich our technologies from different perspectives. The project tackled 5 use cases involving music scholars, content owners, choir singers, and instrument players. Finally, we have music enthusiasts, where I will focus this presentation. We propose the interaction mechanisms for content aimed at people without formal musical knowledge, but interested in learning more about music. So we partnered up with MusicWeb, the music library from the Netherlands. We decided to research the topic of music and emotion since it has been studied for several decades by diverse research fields. Studies have shown that emotion is one of the main reasons why people engage with music, so it is a topic that is relatable and understandable by music enthusiasts. Furthermore, there are several applications of music emotion recognition systems such as emotion-based music recommendation, interactive music therapy, or improving learning environments using music. However, this is still a very challenging topic for the current machine learning algorithms. This is the starting point with the relationship to the computational task. Here you can see a typical definition of the task of music emotion recognition, or MER for short. While there are several different representations of emotions, the system typically is a classification or regression model which attempts to predict a class or discrete value of emotion in music. However, there are several problems that are still open challenges. First, the inherent subjectivity of emotions in music. What a specific listener might rate as happy could be rated as sad by another person. Second, the complexity of differentiating between perceived and induced emotions. Finally, there is an overall lack of agreement between annotators of different datasets. Although several datasets have been opened to the research community, data reliability for the music emotion recognition task must be taken into account. In our previous study, we collected over 30,000 annotations for only 22 songs from listeners with different mother tongues. Namely, we created surveys in English, Spanish, Mandarin, and German. We asked the listeners whether they liked the musical excerpts, if they knew it, and if they had understood the lyrics or not, and assembled different groups of annotations depending on the mother tongue, preference, familiarity, and lyrics comprehension. Firstly, we found substantial differences in the annotations of listeners native to different languages. For example, a song that would be rated as feliz or happy in Spanish would be rated as tender in German. Secondly, and more interestingly, we found that using the annotations of listeners who reported to comprehend the lyrics would consistently improve classification performance. However, this was a very small dataset, so we continued to create our music enthusiast pilots as a tool of annotation and citizen science for the music emotion recognition task. From the point of view of music and emotions, we identified 3 platform design requirements. As to the construction of ground truth, we want to analyze inter-rater agreement, given its impact on the performance of algorithms, and to be able to integrate the annotations collected to other datasets. We want to make a clear distinction between perceived emotions, which are the interpretation of musical properties by the listener, and induced emotions, which are psychological or physiological responses to music. Finally, we want to collect information about each listener in order to enrich our data with personal and contextual information. Regarding individual differences, we gather language and general demographic information when our participants register to the platform. Since there is an impact on the language on the actual annotations, we translated our platform to English, Spanish, Italian, and Dutch so far. Secondly, after a user has registered, we collect information about their current mood which they can describe with a free word in their language, and a visual aid called Pick a Mood for a categorical annotation of mood. We explain to our participants general Western notions of music and emotions. For example, music that has high tempo and major mode is typically rated as happy or high in arousal and balance. On the other hand, slow music that uses minor mode is usually annotated as sad or low in arousal and balance. We present to our participants research from music cognition and examples from the soundtracks datasets from Erola and Voskowski. In this way, our aim is to provide basic music theory to our music enthusiasts as a learning reward for using our platform. The distinction between perceived and induced emotion is very subtle, especially for music enthusiasts. We have found that users might produce both kinds of annotations for the same song. Hence, we explained the reasons that relate to each type of emotion to our participants. Tempo or speed, sound level or volume are properties from music to be judged when assessing perceived emotion. On the other hand, goosebumps or wanting to dance relate more to musically induced emotions. Regarding the annotation task itself, we try to collect several layers of information from each musical fragment. Firstly, we ask our participants whether they liked or knew each song. Then, they will annotate the music with a word in their native language. We also collect positive and negative arousal and balance from Russell's circumplex model. Depending on the quadrant they selected, we present a combination of basic emotions and the Geneva Emotion Music Scale. Finally, they can choose or write the reasons why they used to select each particular annotation. Although this approach neglects the collection of physiological signals for induced emotions, we use the reasons of choice to filter if the user uses a rating for a perceived or induced emotion. Regarding the integration of music emotion recognition models to the feedback loop, our approach is to use active learning in order to produce personalized models for each participant, solving the problem of subjectivity. The aim of active learning is to minimize the annotation cost by choosing unlabeled data instances cleverly, so that the machine learning algorithms will perform better with less training. We use two main strategies for active learning: uncertainty sampling, which uses the machine learning models to find which data instances have highest uncertainty or are the most difficult to classify, and query by committee, which uses several models in order to analyze the consensus across models. The personalization step comes after identifying these uncertain instances and then asking our participants to provide the labels. We can then retrain our models and test on their particular personal annotations. This is still a work in progress, and the integration of the algorithms to the platform is under construction, but we will present the results of our personalization methodology in Izmir this year if you are interested. Regarding the citizen science approach, we considered the importance of explaining to our participants how to make the annotations, allowing for a collaboration between users and scientists by explaining our research and trying to create a community, testing different incentivization strategies, which I will present in a moment, and keeping an open science approach of Trompa of creating open source code and data. Each time a new user comes to the platform, they will find a tutorial that must be completed before they can start annotating. Here, we explain to the participants a bit more on how to correctly use the platform, selection of categories, meaning of arousal and balance, and so on. After an annotation is performed, we offer instant feedback from the annotations gathered by the community for a particular piece. We present general statistics from the dimensional space and the emotion words. We also use music discovery to engage our participants. After a few songs, they receive a recommendation of a song from the user's most annotated quadrant. We use Spotify's API to gather information about why this particular song belongs to a given quadrant, and present this as a learning reinforcement regarding tempo, tonality, and danceability. We also tested gaming as an incentivization strategy. Users would earn more points if their annotation was in agreement with other participants. Although we constantly repeat that the annotations are subjective, perceived emotions are assumed to be more objective, and this is a measurement of the user's understanding of musical properties of emotion. We therefore present a progress dashboard to compare with the rest of the community. For more information on the citizen science approach, I recommend our paper that will be presented at Kotlab Tech conference this year. As to our results, we have promoted several online campaigns due to the COVID situation. The first online workshop collected information from paid participants in order to understand how to improve the design of the platform. We then went on with the first online contest using pop music with lyrics in Spanish and Portuguese, giving away Spotify gift cards as rewards. The second contest involved music from West Africa. This time we used Bandcamp gift cards. Finally, we tried a long campaign using music from different countries in Latin America with a new playlist of 20 songs every day for 30 days without an external reward. We found that gift cards had a significant impact on the number of registered users. Our platform is still under construction, and we hope to learn more about your opinions and feedback in order to improve it. We will still run a final campaign using Prolific or Mechanical Turk to gather more annotations and test our personalization strategies. We currently have over 3,000 annotations for more than 300 music excerpts. Our surveys shows that the main reason to use our platform is simply having fun by listening to music. Data reliability, as defined by Krippendorf, shows consistent agreement with previous research, showing exceptionally low agreement on the emotion adjectives. Finally, an exploratory analysis of the choices of annotations showed that the reasons chosen for arousal and valence relate more to emotion perception, while emotion words relate more to emotion induction. In summary, we have tried to make an approach that involves a human-in-the-loop approach to enrich our datasets and to improve annotation collection. The idea is to have reusable components throughout the whole project in order to take advantage of other partners in the consortium and their developments on other use cases. We plan to complete our research by offering our dataset openly and our open source code for the personalization strategies, which is already available if you want to check it out. Thank you for taking the time to listen to our presentation, and let us know if there are any ideas, questions, or comments to improve our platform.